This is the video version of the notes on topographic maps, which is the second set of notes on maps and the last set of notes for the first unit. Topographic maps are special maps that show elevation with contour lines. The three-dimensional information on a topographic map can show us landforms like hills, mountains, rifts, and valleys that were created through geologic processes. So topographic maps are very much a two-dimensional item, but they show three-dimensional information. They show us differences in elevation. The elevation of a geographic location is its height above or below sea level. On a topographic map, this height could be measured in meters or feet. And if you look at the topographic map on the right, we've got an island, probably some sort of volcanic island that is just a mountain in the middle of the sea. And so everywhere you see blue, it's water. And all the lines represent changes in elevation. So as you walk from the shore into the inner part of the island, you are going up in elevation. Contour lines. The lines on a topographic map are called contour lines. And they're iso lines, iso meaning the same. Contour lines connect points of equal elevation. So if you were on this map here that's shown on the screen, and you walked along one of these lines and stayed on the line, your elevation would not be changing. But if you walked across the lines from, say, the 700 to the 800, your elevation would be changing as you crossed each line. Contour interval is the difference in elevation between one contour line and the next. The amount of change in elevation that occurs between each line. That's your contour interval. It could go up by 5, 10, 20, or 100 feet or meters. Sometimes the contour interval is indicated in the margin, and sometimes you have to calculate the contour interval. In order to calculate contour interval, you're going to have some lines that are labeled. The ones that are labeled are called index contours. They're usually darker, heavier, and they're used as a reference. They're usually labeled with their elevation. The elevation of the index contours can be used to calculate your contour interval. Subtract the lower number from the larger number and divide by 5 for the 5 changes in elevation that occur between the index contours. So you can see here, on this map, every fifth line is going to be labeled, and you take 800, subtract 700, and then divide it by 5. That would be your contour interval. In this case, it would be going up by 20. So from 700, the next line would be 720, the next line would be 740, the next line would be 760, the next line would be 780, until you finally reach the next index contour. So what is the contour interval of this map? How much is it going up by each line? Well, you can see from point C and point D, those are two index contours that are labeled. They are 5 lines apart. You could take 1500, subtract 1000, and then divide by 5. If you did that, you'd get 100. So the contour interval on this map is 100. Rules of reading topographic maps. Contour lines are isolines that connect points of equal elevation. Contour lines never cross. They always run parallel. The contour interval on a topographic map should be consistent. When the contour lines are closely spaced together, you have a steep slope. And when they're widely spaced, you have a gentle slope. And 0 always equals sea level. Hills are shown by circles or closed lines. If there is no elevation info, the top of the hill is just above the last contour line. So in this example, the highest possible elevation is just above the 350. So we know it's not quite 360 because there'd be another line if it was 360. So the highest possible elevation on this map is 359.9. Rivers and streams. Contour lines bend as they cross a river, and contour lines always point upstream, which is the opposite direction of the water flow. So on this particular map, water would be flowing to the southwest. Topographic map shows an aerial view or a bird's eye view of an area along with different elevations. A profile is a side view of the same area, and the topographic map can be used to construct a profile. Hacher marks. Hacher marks are small lines that cross over the contour lines like it is in the image here. They show a depression on the map, such as a sinkhole or a crater. Alright, what is the height of point X? So we determined earlier that the contour interval on this map was 100. So the highest labeled contour line says 1500, but after that there's one more line. So that last line before you get to the top is the 1600 line, and the X is after the 1600 line. We know that the height cannot be quite 1700 because there would be another line, so the height of point X has to be somewhere between 1600 and 1699.9. Calculating gradient or slope. It requires you to know the contour interval and the scale of distance on the map. From point A to point B, you calculate the change in elevation by subtracting. In this particular example, you could say 145 minus 125. There's a change in elevation of 20 meters. And then you calculate the distance by measuring. In this particular example, the distance is given to you, it's 5 kilometers. You divide the change in elevation by the distance, and that's rise over run to get the slope. That's 20 meters divided by 5 kilometers, and you'd get 4 meters per kilometer. Here's another example of calculating gradient. From C to D, the distance is approximately 2 miles using the scale. The change in elevation is a minus 500 feet. From C to D, you're going downhill, so we put a negative in front of it. To calculate the gradient, we divide the change in elevation by the distance, and we get negative 250 feet per mile. It's also important to be able to estimate gradient. If the lines are close together, you have a steep slope. If the lines are far apart, you have a gentle slope, meaning that for Rock Mountain here, which is shown on this topographic map, the easiest way to climb it would be where the gentle slope is in the northwest portion of the map. The hardest way to climb it would be in the northeastern part of the map where the lines are closest together. So, finding the height of point A on this map, A is right on the line that's labeled 4,800 feet. So the height of point A is 4,800 feet. In order to find the height of point B, we probably want to calculate the contour interval first. So we're going to skip point B for now and do the contour interval. We have two labeled lines, two index contours. One says 5,000 feet, the other one says 4,800 feet, and they're separated by 5 lines. Every fifth line on a topographic map is labeled. So if you take your 5,000 and subtract 4,800, you'll get 200. When you divide 200 by 5, you get 40. So the contour interval of this map is 40 feet. To find the height of point B, you have to take your 4,800, add 40, then add 40 again, then add 40 again. And so you're going to get 4,920 feet. The highest possible point on the map is going to be beyond the last contour line, but not so high that you would need another contour line. So from 5,000, you go to 5,040 for that last little circle, and then within that last little circle, the height could be anywhere between 5,040 and 5,080. So the highest possible elevation is going to be 5,079.9. And that's it.